This is Dr. Rebecca Johansson, running and triathlon coach with the Performance Project. You can find us at theperformance-project.com. Today's sports science mini lecture is on exercise and the immune system. The first concept we're going to go over is the J-shaped model. So the J-shaped model was developed by Dr. David Nieman, who's a professor at Appalachian State University, and he's been an expert in exercise and immune function. He's been studying that since the 1980s, so he's a worldwide expert in the area. So the J-shaped model, on this graph, on the x-axis, you have amount and intensity of exercise. And on the y-axis, you have risk of developing upper respiratory tract infection. So on the left side of the graph, you have a sedentary individual, so someone who's not doing any amount or intensity of exercise, and their risk in this model, their risk of developing infection is average. So as we move along the J curve, as we go from sedentary to moderate, so someone who's doing a moderate amount and intensity of exercise, their risk of developing infection is below average, so low risk of developing infection. And then as we move further along the J curve to very high, an individual who'd be doing a very high intensity exercise at a high frequency, their risk of infection goes to above average, so relatively high risk of developing infection. So it is important to note that this is a model. So when you see graphs of a model, it's not results from a study. It is a model based on research that's available, but it doesn't necessarily reflect results of every single study. So here we've got two different studies. These are both from Dr. Nieman's research. And they're going to exemplify what we see on that J-shaped curve. So on the graph on the left, we have a study that was 12 weeks in duration, and they took a group of elderly women. And there were three groups. The highly conditioned group, they did 1.5 hours of moderate exercise every single day. The walking group did 40 minutes of walking 5 times per week. And the sedentary group didn't do any exercise at all. And on the y-axis, that's the percentage of each group that developed a common cold. So in the highly conditioned group, only 8% of that group developed a common cold in 12 weeks. And this was during the fall season. So when the risk of developing a cold is higher than other times of the year. The walking group, 21% of the walking group developed a cold. And out of the sedentary group, 50% developed a cold. So what we see here is that as we moved from sedentary to moderate exercise, it had a protective effect against developing a cold in this group of elderly women. In the graph on the right, this study is now moving from moderate to intense exercise on the J curve. This looked at runners after the week after they raced the LA Marathon, the Los Angeles Marathon. And what they found in that study was that on the bar graph on the left, the marathon runners, 13% of the people who raced the marathon developed an upper respiratory tract infection the week after the race. And then in control runners, this was the group of runners that were training to do the LA Marathon, but for some reason or other, they ended up not actually doing the race. And it wasn't because they got sick before the race. And only 2% of that group developed an upper respiratory tract infection the week after the race. So we can see that racing the marathon did increase the risk of developing an upper respiratory tract infection, but again, 13% is relatively low in terms of numbers. The final concept we're going to go over today is the open window theory. So on this graph, on the x-axis, you've got time in hours, and on the y-axis, you've got immune stimulation. So we're only going to talk about the dotted line, the marathon type exertion. And this theory was also developed by Dr. Neiman. So what this theory says is that when you race a marathon, for example, you've got a high level of physiological stress that happens with racing that marathon. And after racing a marathon, you have what's called an open window, where you've got a period of time after the race where you're going to be more susceptible to developing an upper respiratory tract infection because you're immune compromised for a temporary amount of time. So in this theory, the open window lasts for 16 hours. So it is temporary. And it's also important to note that this is a theory, so it's going to differ depending on the individual and depending on the situation. So when we look at theories and we consider them, it's also important to consider other factors. So I've listed these other factors to consider on the left. So for example, what time of the season, what time of the year are you racing the marathon? Is it in the winter? Is it in the summer? Because in the winter, you're going to be at a higher risk of developing infection versus if it was during the summer, perhaps. Stress level. If you're racing a marathon and you also had a work deadline the week leading up to the race, that's going to impact your risk of developing infection after the race. Sleep patterns, nutrition intake, travel, using public transport. And of course, individual variability. So not every person is going to respond the same in terms of physiological stress with racing a marathon. It's heavily dependent on your training history and if you've raced a marathon in the past and if your body's used to it. So lots of things to consider.